Hello everyone. I'll be explaining a general way to tackle the first part of Trigo R-Formulae diagram questions. The first part usually entails expressing a length in the diagram in terms of theta. Let's understand the question and also understand why a length is a function of theta. A rectangular block PQRS, dimensions 14 by 18, is placed on the ramp Vs at a tilt angle of theta. Theta is not a constant but a variable, so this angle of tilt can actually change. It can get larger, it can get smaller, and it will affect how the diagram will look. The ramp is placed on the horizontal surface ST, so we know this is like a horizontal ground. And D, the one that we're finding, is the perpendicular distance from Q to the line ST. Wherever Q may be, there's always a vertical height, and that's represented by D. So this diagram can actually change depending on what theta is, but it should look roughly the same. However, you can imagine that when theta is, let's say, larger, there'll be a greater tilt and the rectangular block would look something like this. The corner, Q, would then be elevated higher, and you can see that the length D is a different length from what is shown to us here. As theta varies, D would vary. That is why D, this length, is a function of theta. It depends on theta. The other numbers like 14, 8, this 90 degrees, these are constants that will never change. Alright? Okay, so the first step to understand how to tackle these problems is to realize that this actually tests you a lot on trigo ratios, tuakasu. And to apply tuakasu, we require a right-angled triangle. Usually, the right-angled triangle will not be drawn for you unless it's an easy question. In this diagram, we can see a right-angled triangle here. But let me explain whether this right-angled triangle is going to be useful or not. The three essential elements that we need to have in the right-angled triangle that we're going to use are, first of all, of course, there's going to be a 90 degrees. It will be labeled, or you have to label it yourself. There's going to be an angle theta at either one of the other two angles. So currently, the triangle VST, the one that we were looking at, has these two elements, 90 degrees and theta. The third element, and it's actually the most important, is for the hypotenuse to be known. So the hypotenuse of the triangle has to be a known length, like a constant. Look at the triangle VST. The hypotenuse, the longer side, is VS, but we don't know how long this is. We don't know how long it is in centimeters, and neither can we find out based on the information in the diagram. It's important to note that the hypotenuse usually comes from the numbers given to you, 14 and 8. We could also try to understand that since this is a rectangle, there are other constants 14 and 8 elsewhere. So based on the location of the 14s and 8s, we should be trying to look out for other right-angled triangles with all three elements present. Usually we have to draw lines that create right-angled triangles. The lines that we draw are usually horizontal or vertical lines, because all horizontal lines and vertical lines are perpendicular to each other. That's where we're going to create the 90 degrees. Okay, so let's see how do we draw the first line to create a useful right-angled triangle. Let me just focus on where theta is. Currently theta is here, and I'm going to assume that it will build into the theta in the right-angled triangle that I'm looking for. I can see that there's a 14 here. This 14 is going to be the known hypotenuse. I then am required to draw a vertical line from R to the ground ST. Since the purple line is vertical, while ST is horizontal, they are perpendicular, and I get a right-angled triangle. Let me just name it triangle SR, let's call it X. Triangle SRX has all three elements present: 90 degrees, theta, as well as the known hypotenuse. Okay, so once you have such a triangle, you could use trigo ratios to find particular lengths of the triangle. We can see that we know the 14. We don't know Rx and we don't know Sx, but we could find these lengths in terms of theta. Now, which one of these is going to contribute to the question? Which one of these, Rx or Sx, is going to help us find D? We can see that Rx contributes to D. It makes up part of D. Okay? While Sx does not contribute to D at all. So we are going to find Rx. So let me just highlight what we're going to find. And then later we do the working, the full working, to find D. Okay, so Rx can be found and we'll find it later. Now let's try to find the remaining part of D. Let's just draw and visualize where the remaining part of D is. The remaining part of D is here in light blue. If I transfer the light blue vertical line over to the left, okay, so I'm finding this remaining part. I'm going to create another right-angled triangle to find that remaining part. Here we go. So these two lines, these are horizontal and vertical. Again, they are perpendicular. I get a right-angled triangle. I can see that I know the hypotenuse of this right-angled triangle is 8. I know the hypotenuse. I have a 90. I need to know where theta is. I'm going to explain two ways about how you can find out which angle in this triangle is theta. Okay, first of all, let's name the triangle. Let me call it triangle RQY. Finding where theta is, the simplest method, which sometimes isn't so clear, and I'll explain a different method later, is using similar triangles. The right-angled triangles that we create are all similar triangles. The reason why that is true is because look at the first two elements that the triangles must have. They all must have a 90 degrees and they all must have a theta. All of these triangles have these two same angles. Two same angles. Alright? And based on the similarity tests, the triangles would satisfy the angle-angle similarity test. As a result, we know that they are all similar. Using that understanding, let's look at triangle RQY and also triangle RXS. We can see that where theta is in triangle RXS, we can see that it is made up by the hypotenuse and the second longer side. That's theta. We can then look at the corresponding angle in triangle RQY. Let's look for the hypotenuse and the second longer side. The angle between them then has to be theta. Okay. Explaining the second way about how we can get theta, how we know triangle YRQ is theta, we can basically do some working. So I'm going to do this working in black, okay? Let's look at triangle RSX based on sum of angles in a triangle. Triangle SRX has to be 180 degrees minus 90 degrees minus theta, which simplifies to 90 degrees minus theta. Next up, triangle QRS we know it's a rectangle, so that's 90 degrees. Finally, coming to triangle YRQ, because this is a straight line, these three angles are angles on a straight line that add up to 180 degrees. That means angle YRQ has to be 180 degrees minus 90 degrees minus 90 degrees minus theta. And that works out to be theta. Okay, so usually try to use the similar triangles approach, as that will be quicker, no need to do any working. But sometimes if the diagram is not too clear, then rely on working. Alright, so now we have two triangles, RSX and QRY, that have all three important elements, 90 degrees, theta, and the known hypotenuse. Let's use that to find Rx, and then find YR, add them up, that gets us the length of D. Let's try to get Rx first. We can see that based on where theta is positioned, that's the opposite side. We're going to use opposite and hypotenuse to figure out what is Rx. Opposite and hypotenuse, let's use the sine function. Sine theta is opposite over hypotenuse. So now we know Rx is 14 sine theta. For triangle YRQ, finding YR based on where theta is, that is the adjacent side. And we know the hypotenuse. Adjacent and hypotenuse, cosine. Oops, sorry. So cosine theta is YR over 8. Solve for YR. Okay, so we have Rx and YR. We can add them up to get D. I'm also now looking at the order that I'm supposed to, the sequence of terms I'm supposed to obtain. I'm just going to write it in the way that they like. So there we have it, shown. Alright, so just to summarize, to approach this kind of questions, we usually draw vertical or horizontal lines to create right-angled triangles with the three important elements. And out of these three important elements, usually you look for where the hypotenuse should be first, based on the given constants in the question, to know where to draw the right-angled triangles. Alright, thank you.